Hi everyone, Assalamualaikum. In this video, we will discuss example 1 under the graph of polynomial function. Okay. This example from previous semester papers. Given that the function fx equals to x cubed minus 3x squared minus 9x plus 2, find if any, number 1, the critical points, number 2, the interval where the function increase and or decrease and hence determine the extremum points, and number 3, the interval where the function concave up and or down and hence determine the inflection points and sketch the graph of fx, right? Our goal is to sketch the graph of fx, which is cubic function. Okay, so to sketch the graph of cubic function, we need to find number 1, number 2, and number 3. Okay, alright, number 1, find the critical points. Okay, alright, we recall back, okay, the steps to find the critical points. First, we need to find f prime x. Okay, so to find f prime x, we refer from fx, which is equals to x cubed minus 3x squared minus 9x plus 2. And after that, we differentiate using sum and difference rule. Okay, so we differentiate one by one. Differentiate x cubed using power rule, so we have 3x squared. And then differentiate 3x squared, we have 6x. And then differentiate 9x, we have 9 here. And differentiate constant equals to 0. So our f prime x equals to 3x squared minus 9x minus 6x minus 9. Okay. After we find f prime x, we need to set when f prime x equals to 0, we find the values of x. Okay. So now we done find f prime x. Okay. So we continue with step 2. Okay. When f single prime x equals to 0, alright, our f single prime x equals to 3x squared minus 6x minus 9 equals to 0. Okay. Then we can simplify, we divide by 3. So we have x squared minus 2x minus 3 equals to 0. And then we can factorize the quadratic function. So we have x equals to negative 1 and x equals to 3. Okay. Now we done step 2. Right. So after that, to find the value of y, we need to substitute the values of x obtained in here. Okay. We substitute into y or into fx. Okay. Then we write into the form of coordinate because point here means we need to express into the form of coordinate. Okay. So when x equals to negative 1, okay, our y, okay, we substitute into fx. Okay, we substitute negative 1 into variable x in fx. So we get y equals to 7. Okay, and then when x equals to 3, we substitute into variable x in fx. So we get y equals to negative 25. Okay, so now we done find the values of y. Okay, alright. After that, we write in terms of coordinate. So the critical points are negative 1, 7 and 3, negative 25. Right? Alright, now we continue with number 2. Find the interval where the function increase and or decrease and hence determine the extremum points. Okay. To find whether the function is increasing or decreasing, okay, here are the steps. Okay. First, find f prime x. Okay. But we don't find f prime x when we find the critical points. Okay. And then we set when f single prime x equals to 0, find the values of x. Okay. We also done this step when we find the critical point. Okay, so now we continue with use table of sign for f prime x based on the values of x obtained above here. Okay, so now we continue with table of sign for f prime x. Okay, here is the table. Okay, we have two values of x obtained when we set f single prime x equals to 0. We have x equals to -1 and x equals to 3. Okay, and then inside this column, okay, we need to write open interval from -infinity to -1. Okay, means on the left side x equals to -1, x to negative infinity. Okay, and then between x equals to -1 and x equals to 3, we can write open interval -1 to 3. Okay, this is not a coordinate, but this is between -1 and 3. Okay, and then for the right side x equals to 3, we can write 3 infinity. Okay, open interval 3 to infinity. Okay, and then test value. Okay, between -infinity to -1, we can choose any values. Okay, that satisfy this interval. Okay, we can choose -10, we can choose -9, -2, -100, even -1000. Okay, but we choose the simplest value. Okay, and then between -1 and 3, we can choose 0. Actually, we can choose 1 or 2. Okay, but we can choose the simplest one. Okay, alright, and then for column 3 to infinity, let's say we choose 10. Okay, x equals to 10 here. That satisfies the interval 3 to infinity. And then sign for f single prime x. Okay, from the previous slide, we find f single prime x equals to 3x squared minus 6x minus 9. Okay, so now we substitute x equals to -10 into x here. Okay, so after we substitute, we get positive symbol here. Okay, and then we substitute 0 into whatever x here. Okay, so we get -9. But we just consider the sign. Okay, the sign is negative. So we put negative here because this is table of sign. Okay, and then we substitute 10, okay, into whatever x in f prime x here. Then we get positive value. So we just put positive sign here. Okay, and after that, from f prime x, we can find slope or gradient. Okay, when f prime x has positive value, okay, so we can draw a line like this uphill. Okay, and then when f single prime x has negative value, okay, negative value, we can draw a line like this. And when f single prime x has positive value, okay, we can draw a line like this. Okay, alright, this is increasing. This is increasing also. And this is decreasing. Alright. Okay, so we can write increasing from -infinity to -1 and 3 to infinity here. Okay, here is increasing. So we write this. Okay, and then decreasing when x between -1 and 3. Okay, this is not coordinate, but this is between -1 to 3. Okay, alright. And then we need to find the extremum point. Okay, so extremum points mean whether the point is maximum or minimum. Okay, to find maximum or minimum point, if the graph change from increasing to decreasing, means we get maximum point. Okay, alright, from number Roman 1, okay, we have critical point negative 1, 7 and 3, negative 25. Okay, so from here, okay, if the graph change from increasing to decreasing, okay, increasing to decreasing, okay, so we have maximum point here. Okay, and then maximum point when x equals to negative 1. Okay, here. So this is maximum point, right? So our maximum point equals to negative 1, 7. Maximum and minimum points come from critical points. Okay, but the critical point we get before we use table of sign. And maximum or minimum we get after we use table of sign. Okay, alright, and then if the graph change from decreasing to increasing, okay, means we have minimum point. Okay, so from here decreasing and then increasing. Okay, so we have minimum point here. Okay, when x equals to 3. And from Roman 1, okay, from the critical points in the previous slide, when x equals to 3, y equals to negative 25. So this is minimum point. Okay, so our minimum point equals to 3, negative 25. Okay. Alright, now we continue with number Roman 3. Find the interval where the function concave up and or down and hence determine the inflection points and sketch the graph of fx. Okay, so to find whether the function is concave up or down, we can use this procedure. Okay, alright, first we need to find f double prime x. Okay, so to find f double prime x, we refer from f single prime x, which is equals to 3x squared minus 6x minus 9. Okay, and then we differentiate one by one using sum and difference rule. Okay, when we differentiate f single prime x, we have f double prime x. This is the second derivative. Okay, so we differentiate 3x squared, we have 6x, and differentiate negative 6x, we have negative 6. And then we differentiate negative 9, it is equals to 0. No need to write, right? And we need to set when f double prime x equals to 0, find the values of x. Okay, so now when f double prime x equals to 0, okay, means 6x minus 6 equals to 0. Okay, then we have x equals to 1. Okay, after we solve this equation. Okay, and then step 3, use table of sign for f double prime x based on the values of x obtained above. These steps is similar to finding the interval where fx is increasing or decreasing. But for increasing and decreasing, we use table of sign for f single prime. Now, we want to find the concavity. So, we use table of sign for f double prime x. Okay. So, now we continue with table of sign for f double prime x. Okay. Here is the table. Okay. We build table of sign for f single prime x based on the value of x obtained when we equate f double prime x equals to 0. Okay, and when we equate f double prime x equals to 0, we only have one value of x, okay, which is x equals to 1. Okay, so now we have table of sign with x equals to 1 as a border line here. Okay, alright, for x equals to 1 from the left, we can write negative infinity to 1. Okay, and for the right side of x equals to 1, we can write 1 to infinity. Okay, we use open interval symbol. Open interval means we use round bracket symbol. Okay, and then test value. Okay, we can choose any value that satisfies from negative infinity to 1. Let's say we choose 0. Okay, and then for interval 1 to infinity, let's say we choose 10 because 10 satisfies in this interval. Okay, now we use table of sign for f double prime. So sign for f double prime, our f double prime is 6x minus 6. So we substitute x equals to 0 into whatever x here. So we get negative 6, but we just put negative sign only because this is table of sign. Okay, and then for this column, okay, we substitute 10 into whatever x here. So we get positive sign here. Okay, and after that, from f double prime, we can find the concavity. Okay, alright, we refer from this procedure. If f double prime x has positive value, means we have concave up. Okay, now the concavity or f double prime has positive value here. So we have concave up. Okay, concave up is just like smile graph. Okay, when f double prime positive, so we get smile graph here. Smile graph means concave up. Okay, and then when f double prime x equals to negative value here, okay, means we have concave down. Okay, concave down is just like a sad graph. And happen when f double prime has negative value. So this is concave down, right? Alright, then we can write concave up. Okay, is interval 1 infinity. Okay, and concave down, okay, is interval negative infinity to 1. Okay, okay, and after we find whether the function is concave up and or down, we need to determine the inflection points. Okay, so to find the inflection point, okay, if the graph change from concave down to concave up, means we get inflection point. Okay, okay, so now at x equals to 1 here, okay, the concavity change, okay, from down to up. Okay, so if the graph change from concave up to concave down, okay, we have inflection point. Or if the graph change from concave down to concave up, we also get inflection point. Okay, so at x equals to 1, okay, the concavity change. Okay, so there is an inflection point. Okay, okay, point here means we need to find the coordinate of y. Okay, so when x equals to 1, okay, we substitute the value of x into fx to find coordinate y. Okay, so we get y equals to negative 9. Okay, so the inflection point equals to 1, negative 9. Alright, inflection and maximum minimums are the point. Okay, point means we need to write in terms of coordinate. Okay, but concavity and increasing, decreasing, okay, concave up and down or increasing, decreasing here means interval. Interval means we need to get from table of sign. Okay, from where to where? Okay. So this is the final answer. This is the final answer for number 3 for inflection point only. Okay. So after this, we need to sketch the graph of fx. Okay. Right. We continue with number 3. Sketch the graph of fx. Okay. To sketch the graph of fx, we list down all the important points. Okay. The important points are maximum point, inflection point, and minimum point. Okay. We list based on the ascending value of x-axis. Okay. So we draw y-axis and x-axis, origin, and then we point out coordinate x. Okay, -1, 1, and 3. Okay, and then we point out coordinate y, 7, -9, and -25. Okay. Okay, after that we point out coordinate -1, 7 here. Point out the coordinate 1, -9, and point out the coordinate 3, -25. Okay. And after that, we draw a small maximum curve. Okay, at coordinate -1, 7 here. Okay. So maximum point is -1, 7. Okay. And we draw a small minimum curve at point 3, -25. Okay. And then we draw a small inflection point, inflection curve here. Okay. At point 1, -9. Okay. And then we join the graph like this. Okay. So this is the graph of y or fx equals to x cubed minus 3x squared minus 9x plus 2. Okay. Alright, to check whether the graph is correct or wrong, we can refer table of sign for f single prime x. Okay. Alright, from table of sign for f single prime x, okay, the graph is increasing at interval -infinity to -1 here. Okay. Okay. And then the graph is decreasing in interval -1 to 3 here. Okay. So the graph is tally compared to table of sign for f single prime x for increasing and decreasing. Okay. Alright, this is increasing in interval -1, 3. Okay. Now we check for table of sign for f double prime x. Okay. Okay. We have x equals to 1 here. Okay. Here x equals to 1. Okay. And then we have concave up. Okay. For interval 1 to infinity. Okay. And we have concave down. Okay. For interval -infinity to 1. Okay. So this is concave down. So the shape of the graph and the important point is tally compared to table of sign for f single prime and f double prime. Okay. Now we can check the x and y intercept. Okay. So to check the x-intercept, we set when y equals to 0. Okay, y here means fx. Okay, fx is x cubed minus 3x squared minus 9x plus 2. We equate to 0. Then we can solve this QB equation using calculator with degree 3. So we get 3 values of x equals to -2, okay, here, and then x equals to 0.21 here, and x equals to 4.79 here. So the graph and the x-intercept are logic, okay, and then our y-intercept, okay, we set when x equals to 0, we substitute into y, okay, means we substitute x equals to 0 into fx here. So we get y equals to 2, okay, so this is our y-intercept, alright. So this is the graph of polynomial fx equals to x cubed minus 3x squared minus 9x plus 2 with maximum point -17, inflection point 1 -9, and minimum point 3 -25. Right? Coming up next, examples involving graph of polynomial functions. Thank you for watching. Stay tuned. Bye. Assalamualaikum.